All right, number 51. We are asked to find the zeros of this function given that 3 minus I is a zero. All right, so remember with the zeros, if we divide x minus that zero out of the function, we should get a remainder of 0. And what we're left over with will be, we can continue dividing out zeros until we've factored this thing completely. And so let's start there. We're going to start by dividing out x minus 3 minus I. So setting this up with our synthetic division, we're going to put all of the coefficients of this function here. So 1, negative 2, negative 13, 28, 46, negative 60. And out front here, we're going to have our 0, which is 3 minus I. All right, so now let's do this synthetic division. We should get a 0 for our remainder in the end here. So drop down the 1. 1 times 3 minus I is 3 minus I. All right, negative 2 plus 3 minus I is 1 minus I. All right, now here's where this is a little trickier than with real numbers. We've got 3 minus I times times 1 minus I. So 3 minus I, let's just do our work down here. 3 minus I times 1 minus I. So we got to multiply those. So 3 times 1 is 3. 3 times negative I is negative 3I. Negative I times 1 is negative I. And negative I times negative I is positive I squared. All right, so negative 3I minus 3I is negative 4I. And I squared is negative 1. So this is 3 minus 4I minus 1. So that's 2 minus 4I. So that's what we're going to put up here. 2 minus 4I. Let me write that out just so you can see that this is going to be 3 minus 4I and then plus negative 1, because I squared is just negative 1. So that 3 plus the negative 1 is going to give us our 2 minus 4I. All right. So add those together. Negative 13 plus 2 minus 4I is going to be negative 11 minus 4I. Now we've got to multiply 3 minus I times negative 11 minus 4I. 3 times negative 11 is negative 33. 3 times negative 4I is negative 12I. Negative I times negative 11 is positive 11I. Negative I times negative 4I is positive 4I squared. All right, so positive 4I squared is negative 4, because remember, I squared is negative 1. Minus 33, these two in the middle, negative 12I plus 11I is going to give us negative I. Negative 33 minus 4 is going to give us negative 37 minus I. All right, 28 plus negative 37 minus I is negative 9 minus I. So let's multiply that by 3 minus I. 3 times negative 9 is negative 27. 3 times negative I is negative 3I. Negative I times negative 9 is positive 9I. And negative I times negative I is positive I squared. So remember, positive I squared is going to be negative 1. Minus 27, that's going to give us negative 28. Plus 6I. All right, so we put that up here, negative 28 plus 6I. Add that to 46, we're going to get 18 plus 6I. All right. And now we multiply 3 minus I times 18 plus 6I. 3 times 18 is 54. 3 times 6I is 18I. Negative I times 18 is negative 18I. Negative I times 6I is going to be negative 6I squared. Remember, negative 6I squared is the same as positive 6. These two are going to add to 0. We have 54 over here. 54 plus 6 is 60. So we put the 60 up here. Negative 60 plus 60 is 0. So we did get a remainder of 0, which means that this is, in fact, a 0 of this function. And we've reduced this down to, from a 5th degree polynomial down to a 4th degree. But notice what we've done. We've put a bunch of complex coefficients on this now. Well, if 3 minus I is a 0, we know that its complex conjugate also has to be a 0. So 3 plus I is going to be a 0. So let's continue this division here with 3 plus I. And then we've got to do this again, but this one is going to work out a lot nicer. Watch what happens with this. We drop down the 1. 3 plus I times 1 is 3 plus I. Notice that the i's, when we add 1 minus I to 3 plus I, the i's are going to add to 0. 1 plus 3 is 4. 4 times 3 plus I is 12 plus 4I. Again, here the i's are going to drop out because the i's are going to add to 0. Negative 4I plus 4I is 0. Negative 11 plus 12 is 1. 1 times 3 plus I is 3 plus I. Again, the i's drop out and we're left with negative 6. Negative 6 times 3 plus I is negative 18. Negative 6 times I is minus 6I. And those are going to add to 0. And so what we're left with, now we've factored out 2 of our zeros, and we're left with x cubed plus 4x squared plus 1x minus 6. All right, so now we've used up our hint that 3 minus I was one of our zeros. So we're left with this thing down here, and I don't see an easy way that we could factor this. So let's try to guess at one of the zeros of this function. We know that there has to be at least one real 0 because this is an odd degree polynomial. And since the non-real zeros always have to come in pairs, there has to be at least one real 0 here. And the rational zeros test tells us that if there are rational zeros for this, they have to be in the form of factors of this divided by factors of, in this case, 1, which is just plus or minus 1. So the possible rational zeros that we have left here are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Those are all the factors of 6. And so one of those 8 numbers there has to be our 0. So let's just start with positive 1 and see if that'll work for our next 0. So let's bring this down. We'll plug in 1 here. Drop down the 1. 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. 1 plus 5 is 6. Bring the 6 up here. That does, in fact, give us a 0. And so what we're left with here is x squared plus 5x plus 6. And that now we can just factor into, we need 2 numbers that multiply to 6 and add to 5. That's x plus 2 and x plus 3. So our zeros of this function are going to be 3 minus I, 3 plus I, 1, negative 2, because if x plus 2 is a factor, then negative 2 is going to be our 0, and negative 3. So the zeros of this function are 3 minus I, 3 plus I, 1, negative 2, and 3.